Even for experienced IFR pilots, fog can be challenging. It requires the pilots to stay on the top of their situational awareness because fog is often unpredictable and sometimes dangerous. While we're staying on the ground, fog may seem harmless, but it can impact the visibility that can present unique challenges for the pilots. Because of its adverse impact on the safety of the flights, it's important to learn about its different types. On calm, clear nights without wind, especially during fall and winter, in low-lying areas like valleys and regions with little or no wind, you can notice thick layer of fog at lower altitudes near to the ground. This happens because warm, moist air cools rapidly at night as the ground loses heat. The temperature of the air near to the ground drops to the dew point and forms a dense ground-level fog. This is the radiation fog. Radiation fog forms because heat radiates from the ground surface at night, then it cools the bottom air until it saturates. Radiation fog can form at the surface and gradually get thicker as it continues to cool. Because radiation fog is shallow, it has less effect on the flights. But if it gets thick, it can reduce visibility, complicating taxi, takeoff, and landing. When the air becomes warm after sunrise, radiation fog starts to disappear. And the second factor which helps to disappear the radiation fog is the wind. Advection fog forms if warm, moist air moves over colder ground surfaces. This type of fog can occur day or night and is mostly dangerous for the pilots. Mostly this type of fog is common near coastal regions. At these regions, warm, moist air masses pass over cooler waters. Mostly near coastal airports, formation of advection fog reduces the visibility and makes visibility hazards for the flights. We can easily anticipate the development of this type of fog by monitoring surface temperature differences and coastal wind patterns. High temperature differences and wind patterns blowing from land to sea is good enough to expect formation of fog at airfields near to the coastal regions. Have you ever seen fog over lakes, rivers, or oceans? Yes, this is the steam fog which forms over rivers or oceans, especially in colder months. Steam fog forms when cold air moves over a warm water body. The second name for steam fog is sea smoke, for its appearance when it occurs over large water bodies. This type of fog is usually more common in colder months when the air temperature is lower than the water temperature. Steam fog is known by its dramatic and almost wispy appearance as it rises from the surface. Steam fog can form quickly and unexpectedly, reducing visibility near water crossings or low altitude approaches. Absolute fog forms when moist air is forced to rise up a slope. So this type of fog requires consistent wind to drive the air upward. The existence of this type of fog is common along mountain ranges or sloped terrains. It can happen at any time depending on terrain and wind conditions. Fog over mountains increase the risk of CFIT or controlled flights into terrain. The second name for ice fog is freezing fog. However, there are key differences between them that we will talk about it later. Ice fog is composed of thin ice crystals forming in extremely cold conditions and temperatures between 14 degrees Fahrenheit or minus 10 degrees Celsius and typically occurs in Arctic or high altitude environments. Another condition which develops ice fog is when hot, moist exhaust gases from vehicles or aircraft engines mix with the cold air. On clear cold days in the Arctic, an aircraft taking off can produce enough ice fog to greatly reduce visibility, which can prevent other aircraft from being able to take off. The adverse effects of ice fog on aviation is that it requires the visibility and poses a hazard for engine intakes and airframe icing. The key difference between ice fog and freezing fog is that freezing fog involves supercooled liquid droplets that freeze on contact. Ice fog consists entirely of ice crystals formed in extremely cold environments. Freezing fog forms when temperature reaches 32 degrees Fahrenheit or 0 degrees Celsius, and water droplets in the fog are extremely cold and freeze at the time they contact a cold surface like aircraft wings, fuselage, and similar surfaces. The type of ice created will be rim ice, which can be hazardous to the aircraft and airport operations. Frontal fog develops when warm rain falls through the cooler air. When warm water droplets enter cooler air, it will saturate the air with moisture. This type of fog is mostly associated with warm fronts and steady precipitation, and this type of fog is most common during rainy weather when warm air overrides cooler air. Frontal fog reduces the visibility for an en route flight and approaches. To anticipate the frontal fog, pilots should pay attention to meters and tafs for frontal activity and precipitation. For this type of fog to develop, air humidity should increase until it reaches saturation. This happens when rain falls through cooler air and evaporates. This type of fog commonly occurs in conjunction with frontal activity, particularly warm fronts. It might develop during steady or light rain, and it significantly reduces the visibility, often covering large areas. It is usually combined with other weather hazards such as low clouds and turbulence. So colleagues, now we are at the end of our journey through 7 types of fog, and I hope watching this short video presentation help you to increase your knowledge of flying. Thank you very much for watching the video.